What is such a big universe made of? They are categorized into three types. These include normal matter, also known as baryonic matter, dark matter and dark energy are included. But the thing to think about is why there is more dark matter and dark energy than normal matter in the universe. So let's know in this video what is dark matter and dark energy and why did it become dominant over normal matters in the universe. Before that, if you want to know about antimatter asymmetry and antimatter history, you can check the videos on the I button. In this wide universe, matter accounts for 5%, dark matter for 27% and dark energy for 68%. Number 1. Normal matter. All around us that we can touch and interact. These include stars, planets, galaxies and gas clouds. Normal matters are made up of atoms, which includes all visible structures of the universe, which is about 5% of the total universe, and contains only a small fraction of antimatter. Number 2. Dark matter. Dark matter is invisible because they cannot emit, absorb or reflect light. It can only be detected by its gravitational effect on the visible matter. It is like a scaffolding for the universe, which holds galaxies together and plays a role in their rotation. Number 3. Dark energy. Dark energy is a mysterious force which drives the rapid expansion of the universe. This acts like a repulsive force against the gravitational attraction of the matter and causes the expansion of the universe. Although its exact nature is still unknown, it contributes 68% to the universe's composition. There are two well-known reasons for their predominance of normal matters. Number 1. Gravitational influence. Imagine that you are looking at Milky Way galaxy, where the stars revolve around its center, and you consider only the visible objects, like stars and gases. Their speed should decrease as they move away from the center, but they do not. They rotate faster than expected. This strange speed suggests that there is something more than matter, invisible matter. They cannot be seen in galaxies but can be felt through gravity. This invisible matter is called dark matter, which holds galaxies together. Without dark matter, galaxies would move around away and they cannot maintain their structure because normal matter cannot provide as much gravitational pull as dark matter can. On the other hand, dark energy, a mysterious force that pushes everything in the universe apart, which accelerates universe expansion. Visualize it like a blowing balloon. The air in it is like dark energy, which is the reason for its swelling. The greater the expansion, the greater the air. Therefore, dark energy is dominant in the universe. Number 2. CBM. Cosmic Microwave Background. CBM is like a snapshot of the oldest light in the universe. This is the light after the Big Bang, the event that created the universe 13.8 billion years ago. You can imagine the CBM as a baby picture of the universe, which shows what the universe looked like in its earliest moments. At that time, the universe was full of hot and glowing gases. Scientists study CBM light and take clues about dark matter and dark energy from its patterns. This allows us to understand how dark matter and dark energy play a role in shaping the universe. CBM tells us that the universe is flat, meaning it is not separate out like a curve. This flatness is like a balancing point, the point where the total energy in the universe is equal in amount. A certain amount of energy is necessary for the universe to be flat. When scientists sum up the energies from normal matter, dark matter and dark energy, it matches the required amount of energy for a flat universe. This shows how important dark matter and dark energy are in making up most of the universe energy. In simple words, CBM is a powerful tool which helps us understand the early universe, shape of the universe and hidden forces such as dark matter and dark energy. So this was today's video. I hope you learned something from it. And if you learned something new about science, you can subscribe us.